morning students. Today we are going to solve the fifth problem in simplex method. That is the second case, that is called as degeneracy. That is the tie breaking in LPP. That means in the ratio column, if there is a tie between the two numbers, such cases it is called as degeneracy. The procedure has been given to you. Go through the procedure. So directly we will go to the problem. There you can understand how we have to solve that. So this is the problem given. Solve using simplex method. That is Zmax. Zmax is equal to 3x1 plus 9x2 subject to constraint. Two constraint has been given. So constraint has been lesser than or equal to convert it into equations by adding the slack variables. So those slack variables should be added in the objective function by multiplying their coefficient as 0. So form the simplex table. So the simplex table has been given to you. So already I have told how to form the simplex table. So directly I will go for Cj minus Zj. Cj minus Zj 3900, which is the most positive value. 9 is the most positive value. Select that respective column. Once we have selected that, go for the ratio solution divided by respective column element. 8 divided by 4 2, 4 divided by 2 it is 2. So there is a tie between the two elements, that is 2 and 2. Only those two rows are there. If for example there are 3 rows, then for example if it is the 3 number, we have to go for only the tied rows. We should not consider into account the third row or the fourth row. Where there is a tie, only those two rows has to be selected. Then there is a tie. For resolving this type of cases, it is called as degeneracy. We have to select the two rows unit matrix, that is 1 0 0 1, only this. Then how we have to solve means 1 divided by 4, then 0 divided by 2. That is, this is called as the first column, this is the second column. First column element divided by respective column element that we have selected in Cj minus Zj. That is 1 divided by 4, 0 divided by 2. It is 1 divided by 4 is 1 by 4, 0 divided by 2 is 0. So in case of degeneracy, we should take into account 0 as a positive value also. That is the assumption that has been made. It has been given in the procedure. So 0 is for which row? This is the second row. So this row completely we have to select. So go for the next table. Similarly, x2 is the entry variable, u2 is the exit. That is u1 keep as it is. Instead of u2, take it as x2. What is the coefficient of u1 from the objective function? 0. What is the coefficient of x2 from the objective function? It is 9. So once we have got that, you have to identify the key element. Key element is nothing but the intersection of the column and the row, that is 2. So for this particular row, divide all the elements by 2. That is 1 divided by 2, 2 divided by 2, 0 divided by 2, 1 divided by 2, 4 divided by 2. You have got this. So for the u1 column, for the u1 row, you have to apply the formula I have told you in the earlier classes. That is, new value is equal to old value minus corresponding column element into corresponding row element divided by key element. Once you apply the formula, you will get these values. Once you have got that, similarly go for Zj. Zj 0 into minus 1 plus 9 into 1 by 2, 9 by 2. 0 into 0 plus 9 into 1, that is 9. 0 into 1 0, 9 into 0 0, 0 into minus 2, that is 9 into 1 by 2, 9 by 2. So we go for Cj minus Zj. Optimality is achieved because all the values are either 0 or negative. This is negative, 0 0 negative. Optimality has been achieved. Once the optimality has been achieved, go for the solution column also. 0 into 0 plus 9 into 2, that is 18. You have to write the 18 here. So from the final table, what we have to take only the variables x1, x2, x3, x4 like that. There is no x1 term, that is 0. x2, what is the x2 term? From the solution column you have to select. This is very important. x2 value is 2, that is written here. So substitute the x1, x2 value in the objective function. That is, the objective function is 3x1 plus 9x2. 3 into, there is no u1 term from the final table when the optimality has been achieved, so it is 0. 9 into 2, 18. 18 we have got. This is how we should solve the degeneracy problem. If you want to go for the procedure, sometimes the procedure will be asked for you, so you have to go for the procedure also. It has been given to you. Thank you.